Hello everyone, welcome to Baiyun's Tunnel Talk. Today we are exploring the underground world of tunnels and where engineering prowess is showcased at its best. Our special guest is Felix Amberg. Felix is the chairman of the Amberg Group and has played pivotal roles as an executive member of ITA from year 2007 to year 2019. And as the president of Swiss Tunnel Association from year 2006 to year 2012, today he's here to share his insights and experiences from a distinguished career. Felix, welcome to the show. Hagenbach Test Gallery is worldwide and unique. And many Chinese tunnel professionals already visited your gallery. From the beginning to today, it has a history of more than 50 years. So can you please tell me, where did the idea to build such a gallery for underground works?
First of all, I'm glad to be here and to have the opportunity to meet you, my old friend. When you ask me about the Hagenbach Test Gallery, the reason why this gallery exists is, as a matter of fact, very simple. It is my father who initiated it, because my father was mining engineer and he was director of the last iron mine in Switzerland. He used this mine to improve the performance, the productivity, together with the industry. And when this iron mine was closed in 1966, there was still the industry having an interest to have a test environment, an underground test field, because the mine was the test field and it was closed. So they started together with my father to develop and test fields.
So it's a kind of utilization of the space.
And in the beginning it was very, let's say, industry focused. But slowly but surely it also got into other type of activities. Since roughly 30 years, Hagenbach is not only a test field for mining activities and underground construction activities. Hagenbach is what we call is the interface between lab work and the construction site. I mean, you can do a lot of developments in laboratories, but you know that sooner or later they will be on the site. And they must be fully operational when they get onto the site. So you need an interface between the lab and the construction site. Something that is as close as possible to the construction site, but it is a kind of lab where you have no time pressure, where you have no cost pressure. You really can test and make everything happen. So once you are through with that, you know that the material, the new machine, the new process brought onto the site is fit to be used from the very first day onward. So Hagenbach was always at that interface. It started with classical construction industry, drilling, shotcreting, bolting, etc. But then there came additional topics, like for instance, you remember the heavy fires in some tunnels. There was no knowledge there was no software available to evaluate these things. There was a necessity to validate software tools, to validate processes in a very realistic condition, but not in a tunnel in operation. So we started to develop a underground testing and training center for firefighters, for fire emergency cases, etc., etc. Or before these very long tunnels were built in Switzerland, Gotthard Base Tunnel, etc. Some technologies, new materials, new cements, the use of excavated materials as base for aggregates. All this was tested under realistic conditions to be later on be used on the site with a high safety that it will work on the construction side. So Hagenbach always has been in more and more, let's say, fields. This interface between lab and reality. And just recently, we also have established what we call a tunnel digitalization center, where we show how the digital world is with BIM, which is all IoT and all these things, how that looks in reality, to show in real condition how such an interface looks like, how to bring the digital world into the real world, and vice versa.
It is very interesting, you know. I have visited your gallery for several times. And last time I remember you even have agriculture in underground. You know, as you know, I see the ecosystem, the fishery and agriculture in underground. You use the light instead of sunshine.
That is, let's say, this is besides the classical testing and prototyping. This is something we also work on, because in future the underground space will be more important in urban areas than it is, not just for metro tunnels or road tunnels. Modern smart cities, they will make more use of the underground. And one aspect that could be the underground could be used is to produce food. Just imagine in Middle East, for instance, where you have very hot temperatures, very little water. If you put the whole thing underground, then you have 360 days per year you can produce without any rainfall, without any snow, and under optimized climatic conditions. So these are things. We are also in energy storage, high compressed air storages or hydrogen gas storages. We try to also be at the interface between theoretical lab reflections and how this could look in reality. One thing one should not forget with Hagerbach Test Gallery, it is not only an environment to test and to develop, it is also an environment for training and education. And a lot of international companies, international people, they use Hagerbach also for training and education. Hagerbach is actually open to an international community. So if other Chinese people following you, they would more than welcome. And we would love to show them what we do. We would love to exchange knowledge and see how jointly we can further develop underground technology.
As I know, Switzerland is famous in many high technologies in tunneling. For example, the tunnel seismic prediction technology, which was widely used in a Goethals-based tunnel and also different part of the world, which is also very successful in China, and many Chinese projects use this TSP. And I wanted to ask you, and how did this initial spark come from?
In the late 90s, starting with Vereiner Tunnel, that was the first alpine crossing tunnel, roughly 20 kilometers in length. But then later on the Gotthard Base Tunnel. These were tunnels, very long tunnels. Specific is, these are tunnels with high overburden. 1,500 meters, 2,000 meters, Gotthard Base Tunnel even 2,500 meters. And geological investigation from the surface down to something which is 2,000 meters below, that is very costly. And it's only punctual.
Sometimes even impossible.
Even impossible if you have snow there or whatever. So the problem was that too little geological information could be collected prior to the execution of the tunnel. And then we had the idea to say, why spend money on something that is not successful? Let's use that money to investigate the geological condition during construction. And if you have sufficient reach, which means if you can look ahead 100 meters or 150 meters, then you have sufficient time to react on the site. You can improve the support, you can stop the excavation for injection if you have water, etc. So the idea was a geological exploration tool which can be used in these conditions in which you have little to say no information from any other geological exploration methods. So the idea was to bring the exploration into the tunnel and use it during the excavation of the tunnel. That was actually the idea which ultimately led.
You are right. It is not only used for NATM and also for TBM tunnel.
Yeah.